Okay, if you take a look at example 4, we're supposed to evaluate the integral of f of x dx from 0 to 4 if f of x is defined as this piecewise function. And if you recall a piecewise function, well, pick the right one here. There we go. Piecewise function, it's defined for specific values of x. So if x is between 0 and 1, we're doing x squared minus 1. If x is between 1 and 2, we're doing x squared plus 1. And if x is between 2 and 4, then we're doing x cubed plus 2x. The first thing to make sure of is that every single number between 0 and 4 has been accounted for and the function is defined for. So you can see that this is from 0 to 1, not including 1, but 1's included here, up to 2, not including 2, but 2 is included here, up to 4, including 4. So every value between 1 and 4 has been accounted for right there. And as far as the existence of the answers, as far as it being able to be worked out, all these are polynomial structures, so there's no undefined situation. So this is a workable integral. Now, what I want to do here is I want to break this into a separate integral for each different piece. So what I'm going to do is rewrite this problem as the integral of x squared minus 1 dx from 0 to 1. I'm going to add that to the integral of x squared plus 1 dx, and that'll go from 1 to 2. And then we're going to add that to the integral of x cubed plus 2x dx, and that's going to go from 2 to 4. Now if you look at the blue one and the red one, we're not including 1 there, we're not including 2 here. Okay, so theoretically we wouldn't be allowed to do that. But the actual value of the integral at a specific number is 0, so it's irrelevant that that's missing for that sake. The fact that it exists in the original problem somewhere, so 1 exists here, 2 exists there, we're fine with that. So don't worry about that little detail. Each of these is just like we did yesterday. It's just an antiderivative evaluated at the numbers, the top number evaluated minus the bottom number evaluated. So if I do the antiderivative of x squared minus 1, I'm going to need x cubed over 3 minus x, and we're doing that one from 0 to 1. We're going to add to that the antiderivative of x squared plus 1, which is x cubed over 3 plus x. And we're going to evaluate that from 1 to 2. And to that we're going to add the antiderivative of this, which is x to the 4th over 4 plus x squared. That goes from 2 to 4. Keep in mind the plus c is irrelevant here because when you do f of the top number minus f of the bottom number, you get a plus c and a minus c. They cancel out every time anyway, so don't worry about the plus c's on the antiderivatives. I did kind of skip on that one, 2x equals x squared, but I think we're all good at this point. That's 2x squared over 2. The 2's cancel. That's where that came from. Right. So at this point, once I've got all the antiderivatives evaluated, and I got my nice little notation here with this little bracket with the 1 and the 0 and the 2 and the 1 like that. If you recall from yesterday, what that means is that we're going to evaluate this blue function first at 1, then at 0, and subtract. So I'm going to put in 1 for x's. I'm going to get 1 over 3 minus 1. I'm going to subtract 0 minus 0. So I'm putting the top number in first, the bottom number in second when I do that. Next for the red one, if I put in 2 first, I'm going to get 8 over 3 plus 2. And from that I'm going to subtract 1 in for both those, 1 over 3 plus 1. And then for the green one I'm going to put 4 in place of each of those numbers. So I'm going to get 4 to the 4th, which is 256 over 4 plus 16. And from that I'm going to subtract, putting 2 in, I'm going to get 2 to the 4th, 16 over 4 plus 4 squared, which is 4. Okay, just insert the top number in the first parentheses, subtract, insert the bottom number in the second parentheses, and then get what you get. And then we simply evaluate all these individually. 1/3 minus 1 is negative 2/3. Minus 0 we can leave alone. 8/3 plus 2 is going to be 14/3. 1/3 plus 1 is 4/3. 256 fourths is 64. 64 plus 16 is 80. And 16 fourths is 4. 4 plus 4 is 8. Common denominator of 3 looks pretty reasonable. So negative 2 plus 14 minus 4 plus 240 minus 24 all over 3 times 3 to get the common denominator 3 on those two. See, 14 and 240 make 254 positive, and 24, 4 and 2 make 30 negative, and 254 minus 30 is 224. Using our divisibility rules, I know for a fact that 224 does not divide by 3, so I can't reduce the fractions, and 224 thirds would be the correct answer to that problem.